Hello guys, today is the first episode of mini-series about landscape/weather communication. And today we're gonna talk about procedural snow. For this feature and for other, we will use runtime virtual texture support to make our life much more easier. I'll also make use of megascans and I'll show you how to remap the default material with the custom material, and to support all props coming from megascans with the support of weather/landscape communication. What I mean by that? Megascans have a lot of models, trees, rocks, foliage, etc. And to make use of them in an efficient way, we can modify the default material with our custom functions, so all assets inputted from megascans will inherit the same behavior. Also, right after procedural snow, I'll cover rainy state, then some foliage. By foliage I mean some grass support, and also tracks or trails on the surface, so when we walk it will leave the footsteps. Now, as you can see from this picture, snow has some corner cases. We have the multi-layer world. We have water, soil, rock, grass, also mountain, snow peaks, etc. As you know, we have the auto material, and we can use custom brushes. By that I mean we can use some sort of custom layers to paint over our auto material. So they should also behave the same way when the snow starts. For instance, if we have the road or some step inside, I guess, the forest, and when it starts snowing, it should cover it, and when the snow is melts, it should reveal. Also, landscape and objects that are inside the water surface should not inherit snow. And there are some areas, I mean mountain peaks, it's some sort of Z value of the world where snow, even if the weather changes, doesn't melt. Also, you can see it from this preview. I know it's not very big, but you can see the difference. So here we have no snow, here we have snow applied on our surface. The three layers are custom layers, and there are rock props inside each layer. We also have water surface, our big mountain and small mountain. So here the snow is applied on our rock because it's on the same height of this mountain. Now when it starts snowing, our custom brushes and our props are covered with snow, and the elements inside water aren't covered. Also, as you can see, some angles, even if it starts snowing, won't cover with snow. So we should do some sort of this logic. For this, we will use the material parameter collection, also to make our life easier. So changing attributes from one, let's call it database, will apply both in our landscape and our props materials. Now let's start with our logic. So the first step is to activate the runtime virtual texture support inside your project. For this, open project settings, look for rendering tab, and here look for virtual textures. Check enable virtual texture support and relaunch the editor. Next, I guess we'll start with the material parameter collection. For this, I've created the folder where I store all the attributes I need to be applied both for landscape and props material, and I can control the attributes through the blueprints. It's very useful because I don't need any logic consisting creating and supporting dynamic material instances. I can just send the attributes, and all materials that have the same pattern will listen to it and affect. So to create material parameter collection, you just need to press right mouse button, then select material and textures. Here add material parameter collection. When you open it, you can see that you have scalar and vector attributes. Each attribute can have name and the value. For some, like this, it's called conditions. It's vector attribute. I don't care of default value. But for attributes, you can see also it's no snow, height, and no snow fall off. Also always snow, height, always snow fall off. The default values are the values that actually impact our world. So I don't need to adjust them through the blueprint. I'll adjust them here. But in case you need different behavior for different levels, you need to adjust them through blueprints. So make the same attributes, because these values, these attributes, will help us to define areas in the world where snow should not apply at all and where it should always be applied. It doesn't care whether it's snowing or it's not. It doesn't affect with the weather changes. When it's done, let's talk about curves. You can see two curves. Right now I will cover only snow one, because the rain, procedural rain effect on our landscape and props is in progress. So by default, when you actually, for those who didn't see my previous tutorial about weather system, you should watch it. We had the snow timeline. It was the simple float curve, but now when the things are getting bigger, we need to expand our pipeline with more complex things. So now it's the vector float curve, vector curve. You need to create also, I guess I have it wait guys, interaction, weather system here and curves. So I replaced my rain time and snow timeline float curves with the vector curves. To create the vector curve, you need to press right mouse button, then I guess it's in miscellaneous, and here you can see curve. When you press, you can select the type you need. We go with curve vector. So axis here is for the time where the snow should start and also end. The y axis is for when, well, think of the situation when the snow starts, our ground and our props, models in world don't cover with snow immediately. There need be some time pass, so they will start covering. It's like the process. And when the snow actually ends, also this situation is the same as for the rain. We have some sort of after effect. So if the snow and rain stops, puddles and snow doesn't melt immediately. So this green y-axis is for the leftovers or after effects of our snow or rain effect. And our vector curves, as you can see, have values 0 and 24. So it's the timeline of our day. So here from 8 to 9 the snow will start. It will be consistent till 13 o'clock, and then the snow stops at 14 and snow starts melting or ends melting at 15 o'clock. So please do the same both for snow and rain curves. Next, let's cover the blueprint controls. First of all, we need to change rain and snow timeline float curves with the new one, the curve vector. So change variable type, apply changes, then make sure to have change the default references for both of our curves. This one that we created right now. You will receive some errors, but don't be afraid of them. You just need to change some places inside your blueprint. it's in update weather function. So it's here where we actually have conditions about rain and snow. Here we need to replace the old logic where there was get float value from curve with get vector value from curve. The Boolean node doesn't change at all. It's the same. We only change this. We also need to split our get vector value. By default, it looks like this. So to split it, press right mouse button on return value and select split structure pin. Remember that in update weather function, here x-axis is for defining when rain or snow starts. The y-axis is for leftovers or after effects. When you change it for this type of logic, now we need to create another function. I call this function update world feedback. It looks like this. So it doesn't need to have any sort of inputs or outputs. It just needs to be executed under our construction script here, right after update weather. The reason we use it in construction script is so we can change our weather during the level construction to see the changes immediately and to see if it suits our needs. And also under the event graph, when event ticked logic is executed, also right after the update weather here. So update world feedback. We have to set vector parameter values for our collection that we created, this one. Make sure to select conditions, and here is the logic. We use the same type of logic, get vector value, but instead of x-axis we use y-axis, and we use make of color here and here. The reason why we use this type of logic is simple, because in our material we will unpack. Let me show you quick preview. We will unpack the channel and use the value that comes from this channel to make the logic for covering our area with puddles or snow. So the value that we have from our vector curve, it's from 0 to 1, and it will actually be used in lerp to see if it's 0, it means we don't need to cover anything, and if it's 1, we need to fully cover our props, ground, etc. So make it like this. Y for R in both blocks, and it's for rain and for the snow we will use the green channel, G. So when we mask out the red channel, we will apply the logic that is only for our rain state, for puddles, etc. And when we unpack the green channel, it means that we will use the logic for our snow. So, from rain curve to R, from snow curve to G. Here and here. These channels B and alpha right now aren't used, but I guess I'll make use of them in the future. So when it's done, we can continue. As I said earlier, I'll use the Megascan's default material because the library from Megascans is very wide and it has all necessary elements for my purposes. You can make your own master material that will cover props, foliage, etc. and make the same logic there. But for those who use Megascans, you need to press on Megascans plugin, and here I've created, let me show you, I actually duplicated the default material and rename it to my, it's called default material custom, and under 3D material, 3D master material and plant master material, I use my materials. So when it's done, all the assets that are imported from the Megascans will use my material, and all the logic or custom logic that I use there will be applied to them just in few seconds. So it's very handy. Now let's actually adjust the runtime virtual texture. Well, there is very good tutorials about runtime virtual textures and use of them on the Prismatica channel. The link I'll add right under the video, so you can go to this guy's channel. It's incredible person and he made very good tutorials, very entertaining, very well explained. Also, his game is going to be the huge success it will have. I believe in him. So, first of all, you need to search for runtime virtual texture volume in the place actors and drag and drop it to our scene. Now, when it's done, you need to select it here. Then you need to create the runtime virtual texture. I have my here. It's called chapter 1 because this particular I will use on this level. So to create runtime virtual texture, press right mouse button. Then I guess we need to go maybe miscellaneous. Not. So then it should be materials. Yes. And create runtime virtual texture. So when you open it, you can see the default values. For our purposes, for the weather system, we should use more channels. So make sure that texture content is set to be base color, normal, roughness, specular. For some purposes, we can use another runtime virtual texture and to have only one channel, base color or world height, to make some sort of interesting effects. The more channels it have, the more performance it costs. Also, make sure that you have Enable Continuous Page Updates selected. So, this particular attribute can help to get rid of some artifacts. Also, if you have created all the logic, it works, and for some reason when you expand it, it stops working, it means that the size of your runtime virtual texture isn't enough to cover your feature. For this, you will need to expand these attributes. Make it wise, because the higher values is, the more performant cost it will be. Next. When you've done it, select Runtime Virtual Texture Volume. Then, under Virtual Texture, add your runtime virtual texture that you created. And then you need to select with this tool your landscape. So press it, select your landscape, then use Set Bounds. By default, you can see the bounds here doesn't actually inherit the proper pivot. So also use Snap to Landscape, and then make sure to actually change it. So scale is right, but location isn't. So all you need to do is to select your landscape, and copy location from it to Runtime Virtual Texture Volume. Now it's perfectly aligned. You need to do this so your feature won't actually broke. Next, actually, we need to select our landscape. Then, under Detail panels, search for Runtime Virtual Texture, add element and select our Runtime Virtual Texture. Without it, you won't see any changes that we will add to our landscape and our props. So make sure that you have added here. Also, to capture all objects that should be covered with our feature, for all of them in your scene, you need to select them. By default, they won't have Runtime Virtual Texture. Here, they will look like this. Then, to be included to work with our feature, you need to add array element and select our texture. When it's done, we can continue. So, guys, won't be afraid that the voice or the audio quality has changed. It's due to that OBS and my PC could not actually work perfectly with the material graph opened. I guess I need to make some updates, but let's continue. First of all, we need to create the material function I've called my snow coverage that will actually define the areas and the behavior where the snow should be applied and how it will be applied. So, first of all, here we need to add our conditions. It's our vector attribute from our material collection. Make sure to select parameter name here. Here is a lot of them. For this function we need to use conditions. Then, as I said earlier, this function is for the snow coverage, so we need to unpack G channel. Then I use multiply here just to adjust the strength of how this attribute will affect on this noise function. The higher value is, the more consistent snow it will have when the full scene is covered with snow. I use procedural noise node here with these attributes. You can change it to be the texture sample, so you can use texture instead of these nodes. But for my purposes, I found the values that perfectly cover ground and props in the same behavior. So you can use this gradient computational here, high quality, scale. So the lower scale is, the more, I guess, I'm sorry guys, I don't remember the words perfectly. So the lower value is, the more the higher values of noise patterns there will be applied on the ground. Also, I deselected turbulence and make levels from 6 to 3, so the frequency is changed and the shapes of noise are more suitable for me. To make sure that you don't need this node and you will need to have the texture instead, you need to search for function input. Here you'll need to select function input texture 2D and use texture sample applied like this, and only then mask R, G or B channel. It depends on whether you have multicolored texture of noise, where in every channel stored some particular pattern, and just select it like this. Then in the input, when you use this function, you will need to provide your texture. So this G channel is from 0 to 1. So from it we will subtract the noise. So the behavior of snow will be like covering particular areas, so it will fake some sort of animation how snow is applied and how it smells. And we use this in our B lerp channel and this one as the alpha. So when we have 0, it means we don't cover any area, and if we have 1, we'll cover it with these particular computations. Then we saturate it and multiply by this logic. We use material function height_lem, the one I created in my previous tutorial, where for the height falloff and height I use the values from material parameter collection, snow falloff, snow height, both in these channels, and this means that this area won't be covered with snow even if it's snowing. This one is for our underwater areas. Then we add this particular logic. It's the same as we have here, but with these values. So by adding this logic, we will define that this area that is covered with the particular values on that axis will always have snow. It's like mountain peaks. Then we saturate it, and the reason why we use it, because this particular function will be used here and here and here as the alpha for blending between the material attributes. So please take a look one more time. Play around with these values here or with your texture. Also make sure to properly adjust the curve inside your vector curve of snow. And let's continue with, I guess, another material function that is called layer over paint. This one. It's actually I made it as a function, but I got this idea from Prismatica. The link is below this video, as I said earlier. And the reason I use it as the function, because I don't like to have mess on my graph. So if I use it like this in this material instead of this function here, it will be a disaster. And I also want to reuse it for not only snow but for rain and other effects. So what do I have here? I won't make the breakdown of this particular function. I'll just show you the basic idea, and you can actually watch the tutorial on Prismatica channel. So we do need to create some inputs. It's all scalar. Also make sure I'm sorry, so they will have the particular input name. Layer here is for the runtime world texture output, the information that we will gather from our landscape. Coverage here is for the amount of how much area of our props will be covered with the particular snow, rain, or other effect. Then we use vertex color, and this particular operation, as Prismatica said, don't get me wrong, we do need to use subtract, and the A value should be 2 to start the effect working properly. Next, well, actually this particular function helps us to cover particular areas, only like top areas of our props with snow or rain. So if we take a look Here you can see that this particular props isn't covered on these areas, on these angles, because we use, we use z-axis of pixel normal and vertex normal attributes, nodes. So if we used another channels, then other areas will be covered with it. Next, we also need to have overpaint height and mask type. Overpaint height is for the accumulating the effect of snow on top. So when this particular logic is applied, we'll define that from the top of our props, from this area, our snow will be accumulating, making some sort of pillars. Let me just demonstrate you quick. Now, well, it's actually right now is covered fully, but you can see that the height of the snow is changed. Yep, this looks much better. So, what you also do need to have here. Hardness. And I guess that's it. Let's actually talk about the mask type. This input is used to, it's actually the alpha, and it defines the behavior, how actually our snow is applied on the surface of our prop. So I use it with my function that we have created earlier, snow coverage, with this one. So when it's applied, all this logic here works properly. So now let's talk about the output. I have three outputs. Layer, here, normal blend, because this type of operation, when we apply our mask here, our mask type here with the vertex normal world space, we will actually be blending between two normals, the one without snow, and when the snow is applied, it should be applied instead of the previous one. And this type of operation here also with the world position offset that we will use to multiply or accumulate the snow on top of our props. So to accumulate it in a proper way, we need to use the make floor 3 on the z-axis, so our areas on x and y won't be affected. And here how it looks in my master material. So layer, it's in the information that tells us to blend between the base color of our prop with the base color of the snow layer. Also, normal blend and world position offset are blend between the previous state of our props with the values from the snow layer. Make sure to copy it properly. Also make sure to saturate the proper outputs because they are used as the alpha from 0 to 1. Also, it's very useful to have this logic done because right now if we start rotating our object, you'll see that only top of these props is covered with snow. So it doesn't depend whether how we have rotated. It's very useful for the level design for artists. So when it's done, we can actually continue with two last topics. It's our landscape material and our master material, props master material. And let's start with the landscape. So this graph is, or maybe familiar to you, but it has some changes. So I have extra layer blend with the material layer of snow and the function snow coverage here, right before the rock layer is applied. So it means that we have the default state here of blending snow and grass. And when the snow is applied with this material function, this particular layer is actually withdrawn with this one. Rock and snow is the same, and making this logic here actually leads to more realistic behavior. So rocks are covered with snow here and are not covered on the proper angles. Next, in the layer blend here, I did make logic so even the painted layers should be also covered with our snow. I mean, if we have the auto material and we have painted layers with the brush over it, the logic should stay consistent, and if it snows, our painted layers should be also covered. So for this I use also material blend between each type of layer and snow. And snow is just snow. Also, here comes the usage of runtime filter texture. We can have only one runtime filter texture output in the material, so please make wise decisions how to use it, how to use these channels. I'll make use of specular. It's for snow. I guess for rain I'll go with the roughness. And this channel is from 0 to 1, so to make sure that the information from the landscape is provided inside our master prop material here, I'll gather all my layers and add them one by one. Soil, grass, rock, snow, and auto material. Then I saturate it and apply it here. When it's done, auto material and all painted layers now will properly affect when the weather changes and the props are located in proper areas, like this. So, take a quick look one more time. And now let's talk about the props master material. So, right after the adjustments here, it can be your material with the all logic arranged. Then make sure that your master material uses material attributes. This one. I'll use get material attributes here and set material attributes here. So I don't need to use break and make. I just make changes on particular channels and don't need to have them as and to align every pin that isn't changed. Also I have static switch parameter which is called not overpainted. So it means that if I don't want to have my object be painted with the snow at all, like let me see, I had it somewhere here. Yep, like this one. For instance, if I have the situation that the snow is going outside and I'm sitting in the house, and to prevent some complex logic to see if it's snow and if it's colliding with something, then stop it, etc., etc., I just select the material of the prop is used, and inside it I have not overpainted, and by default it's set to true. So I do need to unselect it to be overpainted only for those assets that should be covered with snow. So all assets that are placed in scene and should be covered with snow, they should have applied, I mean not applied, not overpainted checkbox here, so they will be overpainted. So for instance, if I now select it like this, you'll see, let me wait for shaders to compile. That now they aren't covered with snow. Everything is simple. They now uses only their default material attributes. Now let's continue. Well, actually I think that using base color and normal and lerping between them is actually enough to fake the weather effect on your prop. You can use roughness, specular, and other channels, but I make use only of those two channels. It's my own decision, so go with your own logic. If you don't like this one, it will also work. So make sure also that you have the material layer of snow added here, the one that we use inside our landscape material. And here is the logic. If it's not overpainted, then I use the base color of my prop, also the base normal. And if it's false, it means that it should be affected with the weather. I'll use the information from my layer, this one, and as alpha we use the layer overpaint function, this one, with this particular attribute: snow coverage, snow hardness, snow height, snow coverage function, this one that tells how and where the snow should be applied, the behavior of it. Snow height is the world position offset of our snow accumulated. Coverage and hardness defines the look of the snow is applied. Layer output goes for the base color here, normal blend for the normal blend here. World position offset by default is set to be false, and if it's false, it means that we don't need to change any world position offset of our material, and if it's true, it will take this attribute value. And by default, all the props in my scene aren't affected with my weather. Also, if you use get material attributes and set material attributes, provide them with the proper channels that are changed. And here's another and the last topic to talk. We use runtime water texture sample. Make sure to provide the texture we created and that it should use the proper texture content, and use world position inside world position, because without it, it won't work properly. And specular. So, specular channel. Here, we use the information about layers in our specular channel. So, to sample the texture, to use the information from our landscape here, we use it from our specular channel here. And when it's done, you'll see that everything works fine. Let me just revert the behavior of my props. And now if I change the weather, you'll see that everything works fine. Here is the particular high so the snow doesn't melt. For props underwater, there is also nothing changed. The rock cliffs, due to their angles, aren't covered with snow. Other areas are covered with it. Also, our custom painted layers are covered with snow too, and the objects that are crossing these layers will also receive the snow information. So, if I don't provide the support of runtime rule architecture here, let me just go with only auto material sample. You'll see that now, without this logic, the objects that are crossing the hand-painted layers won't be covered with the snow. They won't receive any information of it. Let's just wait for shaders to compile. I'll stop it and show you when it's done. So, shaders start compiling. Now, if I change my time and the weather is changed and it starts snowing, you can see that objects that aren't or are across the painted layers just don't work properly. Only where the auto material is applied. So, that's all for this tutorial. There are some topics that are not covered, but they will be covered soon when we talk about the rain, because when the snow is melting there should be some puddles, and I'll cover it with another technique in the future video. So I guess that's all. So please leave your feedback, subscribe if you like my videos, leave your comments, and right now I am going to make the Discord channel so you can have my support. Well, see you soon.